Hello young people, it's Miss Stover again. Today we're on our bonding journey 2. We're going to be talking about ionic bonding, but this time methods of finding the formulas. Today we're going to try to figure out what methods we could use to find ionic formulas and how we could use that. Writing correct formulas for binary ionic compounds and correctly naming binary ionic bonds, even with the D block metals in them. So we have to make sure that we figure that out. So we've got a couple things that we need to be looking at. So I first want to talk a little bit about the ideas of dot structure versus a couple other things. So I'm going to do a couple of dot structures. So I have, let's do aluminum. Aluminum has this dot structure, right? We know that. And we know that oxygen has this dot structure. Okay? Now we know something about those dot structures because of what we see. We know that because aluminum has 3 dots, that means aluminum is going to form aluminum with a 3+ ion. And we're saying, well, the 3+ is the charge on the ion, but the 3+ tells us a little bit more. This 3 tells us the number of electrons. And the plus tells me that those electrons are going to be lost. So when we decode that information, we can see that that is actually giving us the exact same information as our dot structure. That we have 3 electrons in the dot structure, and we know because aluminum wants to be octeted, it will lose those 3 rather than gaining the other 5 that it would need. So it's going to form a 3+ charge, but the 3+ charge tells us that it's losing 3 electrons. So if we look to the next element that we put up there, which was oxygen, we know because oxygen has 6 valence electrons that oxygen is going to form O2-. Well, what does that tell us? It really tells us the same thing that the aluminum did. In this case, we know that there are 2 electrons, so we have the number of electrons, and because we have the minus, it tells us that those are gained electrons that are going to be gained. So we can see that dot structure and charge are related to one another. So when we get to a situation where we don't have a dot structure, where we're not able to determine a dot structure, then we can find that there are some other situations that we can deal with. Okay, so let's move on to the next slide and see what we've got. Okay, my hair is kind of in the way. So the dot structure method, we already know this. I mean, dot structure method is pretty easy. So if we go back to the 2 that we were looking at, we have aluminum with 3 dots, right? We have oxygen with 6 dots. We know that aluminum wants to give away its electrons, so aluminum will give away this electron to oxygen. Aluminum will give away this electron to oxygen. Well, oxygen is now satisfied, but aluminum is not. So we already said, well, that means we need more oxygen, something that will take more electrons. Since we started with oxygen, we have to stay with oxygen. So then we say, okay, aluminum is going to give this electron away to oxygen. But now aluminum is satisfied, but oxygen is not. So we go back and we say, okay, we need more aluminum. Sorry, we need more aluminum. So we have aluminum with 3 more dots that comes in, and we know that that gives that one away to this guy. Well, hang on, he's satisfied now. So 2 oxygen satisfied, 1, but this guy is not satisfied. So again, according to what we've done, here we go. 1 more oxygen. So here we have aluminum giving away this electron to oxygen. Aluminum giving away this electron to oxygen. This oxygen is satisfied. This aluminum is satisfied. And we can see we have 2 aluminums, Al2O3. And we know that this is called aluminum because the metal gets its name. And the O, because it's the anion, gets an "-ide" ending, so oxide. Pretty simple stuff when we think about it from that perspective. And that's the dot structure method. Now I have to tell you, the dot structure method only works. It only works. Excuse me, I have to erase a few things. It only works with S and P block elements, the representative elements. That's the only way it works. It does not work for anything that is not an S and P block that we don't know a dot structure for. So it kind of falls apart because we can't do it for things that are in the D block. So the visual plus and minus method. So I'm gonna do one here for you. So we have Fe, and Fe has 3 plus charges this time, and we have S that has 2 minus charges this time. So we already know that's 3 electrons lost and 2 electrons need to be gained. Well, how can we do this without dots? Because we don't have a way to draw a dot structure for iron. We didn't learn how to do that, and it doesn't look exactly the same, and I'm not going to teach you something that's not correct. So if we look at this, Fe, well, what if we represented the charges with pluses? Because pluses tell me that I'm losing, and I'm losing how many? 3, so 3 pluses. And S will get 2 minuses. We know for every plus, it needs to give away to a minus. So for every electron, we need to be able to give it away, okay? So we know we need more places to give electrons away. So here we go, S. So for every electron we have to give away, it has to be given away. Well, now we need more donations. So we go back to Fe. For every plus, there is a minus. Well, now we have extra plus. For every plus, there is a minus. For every plus, there is a minus. Well, now we can see that this is called Fe, or this is formula is Fe2, S3. Now, the name is a little different because it's iron from the D block and it's got a 3 plus charge. We have some ways that we can do this. We can either call this iron, we can either call that iron 3 sulfide. 3 meaning the charge on the iron, or we could also call it ferric sulfide. Okay, I'm having a little trouble. Sorry. Ferric sulfide. Okay, so those are the two things that we could call that, and that's according to the purple sheet that you were given today. And amazingly, this method works for every single combination of anything we could possibly do. So if you're a very visual learner and you need something visual, this is your method. And eventually most people will get to a different method that's a little bit easier to work through, because this one seems tedious because you have to write a lot of pluses and minuses. But I'm telling you, if this is the only thing that your brain is understanding, use it. Don't use anything else. Use this if this is the only thing your brain understands, okay? Don't choose a method your brain is not working with, because you have to be able to get the right answer. All right, the next one is the least common multiple method. Well, let's use our same example. We have Fe 3 plus, we have S 2 minus. Well, what we know least common multiple is the number that both of these numbers go into evenly, that's the smallest number possible. So the smallest number possible that both go into evenly. Well, with a 3 and a 2, we know that that is 6. So that means I need to lose 6 electrons, and I need to have 6 electrons gained. So to do that, what I'm going to do here is I'm going to multiply this 3 plus by 2, because I need 2 of those to get to a 6 plus. And I'm going to multiply this 2 minus by a 3, because I need 3 of those to go to a 6 minus. Well, those numbers represents the number of each of those ions that are needed to make a formula that has the same number of electrons lost and gained. And again, same answer we got before, Fe2, S3. Exact same answer. And again, it would still be called iron 3 sulfide or ferric sulfide. Either one will work, okay? The iron 3, the 3 represents the charge on the iron. It doesn't represent the number of ions, it represents the charge on the iron. okay? So this method works again for every combination. So the last two methods that I've shown you work for all combinations that you'll ever possibly do in this class. They will work for everything. So again, I'm asking you to choose the method that fits best with your brain. The last method is called the switcheroo method, and most people find that the switcheroo method is the easiest method to do. However, not everybody completely understands the math behind what's going on. And I'm going to tell you the math is similar to what we did in the last one. But there are some exceptions that happen here. And if you don't understand those exceptions, don't use this method. Okay? So what this method says is the 3, that is the positive magnitude, becomes the number of the negative that you need. And the 2, that is the negative magnitude, becomes the number of the positive you need. So that means my formula will be Fe2S3. And that happens to be right because we're basically going back to the idea of least common multiple. And that's where the fall apart occurs. If you don't understand least common multiple or don't understand how to determine that, then when you get this, you're going to get situations in which you're going to get bigger numbers than you need, and you're going to be wrong. Those occur when things are multiples of each other, like a +2 and a -4, or a +4 and a -2, or a +6 and a -3. Those kinds of things will occur. Also, if you have the same magnitude, a +2 and a -2, it's not 2 and 2. It's 1 and 1. They cancel each other out. So if you don't understand the exceptions, this method falls apart and has exceptions. If you don't understand the exceptions, don't use this method. It will not be one that you understand at this moment. Maybe you will eventually become to understand it, but right now it would not be a good method for you. So I want you to really look at these 4 methods, and I want you to choose the method that your brain, not your neighbor's brain, not your best friend's brain, your brain best understands. That's your best bet right now. If at some point in time you begin to see a pattern or see something that starts making sense to you and you want to switch to a different method, that is perfectly fine. But right now, you find the method that your brain understands the most and you stick with it until you figure something else out. Because all of them have revealed the exact same answer for the exact same problem that we did. Okay? So please take some time to do worksheet 2 tonight for 2nd, 3rd, and 6th period. For 1st and 4th period, please kind of marinate on this and figure out a way that you think is best. Even redo some of those problems that you may have gotten wrong and see which method is best for you and that you understand the most. So take some time to do that.